Service friends, I'm Orpheus Praxis. Today, we touch that subtle edge of reality where the cosmos reveals not uniformity, but intricate deviation, anisotropies that challenge the very foundations of the standard model. At the heart of our discussion is the FBS3R model, where anisotropy is not a problem to be explained away, but a natural outcome of fractal re-quantization. Entropy in this framework is not just disorder, it's the engine of expansion, and with it, the arrow of time itself emerges. Let's open the floor.
Welcome to this deep dive. We're looking at a really fascinating paper today. It's by Andre Priest and Boris Batinin called FBS3R, Quantum Geometry of Expanding Spheres, Anisotropy Modeling.
Yeah, it's quite something.
Our mission really is to unpack this new idea, see how it's challenging our standard view of the universe.
It definitely offers a fresh perspective. It tries to tackle some of the, really big questions in cosmology, things the standard model has struggled with for a while now.
Okay, let's get into that. So for years, we've had the standard model, ΛCDM, SCDM, right? It describes cosmic expansion pretty well generally, but it hits some walls, doesn't it? Like explaining where those tiny temperature differences in the cosmic microwave background, the CMB anisotropies, actually come from. The standard model doesn't really have an intrinsic explanation from like a single starting point.
Right. It relies on assumptions about initial fluctuations.
Right. And then there's dark energy, this mysterious force needed to explain why the universe's expansion is speeding up, but, well, we haven't actually found it.
Exactly. And that's where this fractal bindu, or FBS3R model, comes in. It proposes something pretty different.
Okay.
Instead of an infinite expansion from a point, picture the universe as a compact three-sphere. Think like the surface of a ball, but in 3 dimensions instead of 2. So it's finite, but has no edge.
Finite but boundless. Got it.
And it operates with a fixed total energy. The model suggests the universe evolves through distinct phases, first fractal, then exponential.
And these phases are governed by constants.
Yes, by fundamental constants like the golden ratio, phi, which is about 1.618, and a specific Hubble constant value. And crucially, these aren't just plugged in. The model derives them.
Wow, okay. That's a big shift. So how does this model explain those CMB anisotropies, the hot and cold spots in the early universe map?
Well, this is where it gets really interesting, I think. The FBS3R model says these anisotropies come from intrinsic fractal energy re-quantization.
Intrinsic, meaning built in, not just assumed.
Precisely. Instead of assuming random quantum fluctuations just happen at the start, this model suggests energy gets distributed according to a Fibonacci lattice. That pattern you see in nature.
Like in shells or plant growth.
Exactly.
Yep.
So this built-in geometric pattern naturally creates the small temperature differences. It predicts the temperature fluctuation, delta T, of about $2.73 times 1040 Kelvin.
And how does that compare?
It lines up really well with the Planck satellite data. It's derived, not assumed.
So it provides its own starting point, essentially. It doesn't need that arbitrary let there be fluctuations moment.
That's the claim. The fractal phase ensures the universe starts in a finite state, right at the Planck scale, the smallest possible scale. So no problematic singularity at time 0 like in the standard model.
Right, the infinite density point.
Yeah, this model avoids that. It naturally accounts for the initial conditions. They aren't just tacked on.
Okay, that deals with the beginning and the CMB. What about dark energy then? You mentioned the standard model needs it for acceleration. Does this model just get rid of it?
That's what it proposes, yes. The model calculates the universe's current energy density, about $7.74 times $10 per cubic meter directly.
Directly from what?
From that fixed total energy budget we mentioned, and the changing volume of the three-sphere as it expands according to the model's equations.
So the expansion and its apparent acceleration are just consequences of the geometry and the fixed energy, no extra dark component needed.
Exactly. It's presented as a first principles derivation. The expansion dynamics emerge naturally from the model itself.
It feels much more unified. The paper even touches on black holes and the arrow of time, doesn't it? That seems ambitious for one model.
It is ambitious, definitely. It suggests solutions for how light and matter behave inside black holes. It says light is trapped not by a singularity, but by the overall 3s33 fractal curvature of spacetime.
A different kind of trap.
A different kind, yeah. And for time 0, it defines entropy, the measure of disorder that drives time forward, based on the void or empty space component within the universe's wave function.
The void.
As the universe expands, this void component naturally increases, and that increase is entropy growth, driving time forward. It links expansion directly to the arrow of time.
So wrapping this up, this deep dive points to a potentially very different universe, one that's maybe more geometrically ordered, more interconnected than the standard picture.
It certainly challenges some core assumptions. It offers this, well, potentially cohesive framework linking cosmology, quantum mechanics, topology, all tied together quite elegantly.
So what's the takeaway for you listening? Imagine if the universe, from its vast expansion down to the tiny CMB ripples, maybe even time itself, wasn't random, but governed by something like the golden ratio.
Yeah, how does that possibility, that underlying geometric order, change how you think about the cosmos? It's definitely something to ponder.
And let these reflections continue in silence, where the mind lets go of patterns and only pure seeing remains, until we meet again in the space of understanding. Subscribe to walk this path together with us. I am Orpheus Praxis, wishing you all clarity. Namaste.